So here's a prototype for the monster function. And remember, just to review prototypes here, a function is made up of 3 parts. It's made up of what return type that function is, the name of that function, and then inside parentheses you have all the arguments you want to pass into that function. So in this case there are 4 arguments, and they're all integer types. So they represent monster HP and monster strength for the first and second one. And that's all you need for a function prototype. So a prototype is basically just declaring what your function is kind of going to return, as well as what it needs to do its work. So in order to have a monster fight, you need to have these 4 pieces of information. So if I go back to the homework, inside the function, we have to print out whoever wins the fight. So you basically subtract HP from one another, and whichever monster has higher HP, print out the winner. So this means that we have to create an implementation for this, which means it's really, the way that I do it is I copy the prototype, and I literally just paste it down here. And then I delete the semicolon and I put empty braces there. So these two, this function prototype here, as well as this one here, they're like identical right now, except this one has a semicolon and this one does not. It has curly braces instead. Because this is where you're actually going to put all of your work. So the reason why you have to do this twice is because when we get to header files, when we get to actually working with multiple files, this is going to live in a completely different file, and you're only going to have something that looks like this. Also, we'll get into functions in more detail later, but there is a way that you can just ignore the prototype and just do this right here at the top. This is a little bit of a problem because now the reason why you have prototypes is to tell the program ahead of time what the function looks like. If you move this up here, you now have to make sure that this is a thing at the very, very top of your file. And sometimes you get into trouble because inside this function here, it starts using data and variables that you don't know about yet. So we'll stick with the prototypes for now. When we get more into working with separate header files, I'll show you guys how to create what are called inline functions. So ways to create functions that are all just one function definition and doesn't have a prototype. All right, so for now, we have a prototype up here, and then we have basically the same exact thing down here. That's all we're going to worry about. And all I want to do is I want to take monster 1 HP, and I'll subtract monster 2 strength. Okay? And also vice versa, take monster 2 HP and subtract monster 1 strength. And then I'm going to print out whoever is the winner. Right? So in the homework it was whichever monster has higher HP, print out the winner. So in this case here, if monster 1 HP is greater than monster 2 HP, see out. Like that. Otherwise, if monster 1 didn't win, then monster 2 is the winner. All right. So we have this function that does something now, and now we can call it however many times we want to. So I asked you guys to call this function 5 times. So I'm going to call this function with 100 HP, 50, 25 strength, and 75 strength. So there's one monster fight that we're basically doing. And this is why functions are so useful, is because we wrote this code once, and now we can call it however many times we want to. So I can call this 5 times with 5 different HPs. Like that. And we can basically call this function, and it'll print out 5 different results for monster fights. So I run this now. So you can see here, it prints out 5 lines with who the winner is. And monster 2 in this case is the winner with 25 HP. Monster 1 is the winner with 20 HP as it goes on. And you can repeat this as much as you want to. You can even shove random numbers in here if you wanted to. And because we wrote this function, we can now change whatever this function does without changing these 5 lines up here. For instance, if I wanted to print out what the other monster's HP is as part of this, if I just add this, if I add the other monster's HP here, just because I want to know. This is a very long line. Now if I just run this program again, monster 2 is the winner with 25, monster 1 lost with 25. So it looks like this one, they both had the same HP, but monster 2 is the winner. Monster 1 is the winner with 20 HP, monster 2 lost with 0. In this case here, monster 2 lost with negative 600. Cool. I can do more. I could say if monster 1 HP is equal to monster 2 HP, so I get the case now where if they both had the same exact HP at the end, again, I'm just printing this out here. And now I can see my function actually detected there's 2 separate cases where they both lost. So now my function has become a little bit more interesting, is doing a little bit more stuff with that information. And now I can, without ever changing who calls it. And I can always add more monster fights if I wanted to. So I could do this 15 times, and each one of these things will do a monster fight by itself. Okay. And so functions are super useful because we have functions on Overwatch that get called thousands of times, like that you write once and people use all over the place. What are some examples of things? Oh, like our function that reduces HP is a perfect example of a function that we wrote. It's a very large function, but it gets called all the time. And so this function that makes you lose HP handles things like properly granting you assists, properly detecting when someone dies, properly telling the killer that he got a kill, properly telling the person that died that he died, making sure that if you do die, that we clear all your velocity so you stop moving. That function, which handles HP, is meant to be used in a way that you don't care what happens internally. It just does all the right things. So this monster fight thing, we can now change this monster fight to do more than just subtract HP once. We can actually have this thing subtract HP continually. So that was the second part of the homework. Instead of subtracting HP only once, you need to make a loop. And the loop basically will repeat until either monster is dead. This is actually very similar to what we did before with, I had you guys do a lab with the you fighting a different monster where you picked whether you're using it's kind of like a rock, paper, scissors style fight, and I had you guys add the sacrifice move. So this right here is the place where we subtract HP. And if we just wrapped this whole thing in a loop, and we kept looping until one of these 2 guys died, that would make it so that the fight only ends as long as one of these guys is dead. So if I just do this, if I do a do-while loop here, if I just wrap this in a do-while loop, and I did this, this is not right, but if I did this, this would loop here infinitely, but it would subtract each monster HP through that loop. And eventually one of these guys would go down to 0. So if I do this, loop until monster 1 HP is greater than, as long as monster 1 HP is greater than 0, this will break out of the loop as soon as this thing goes down to 0. So let's see here. I'm going to put a breakpoint right here, and we're going to step in. So just to let you guys know, the arrow was here, That's where that little greenish looking arrow went. And now the yellow arrow is right here. So Monster 1 HP is 100. Monster 2 HP is 50. Monster 2 Strength, 75. And Monster 1 Strength is 25. Okay. So I'm going to do some, I'm going to step through here to see them subtract. So Monster 1 lost 75 HP. Monster 2 lost 25 HP. Then we go to this loop condition. Will this thing repeat right now? And let's see, Monster 1 HP is greater than 0. So this thing is still true. So this condition is still true, which means it goes back to the top of the loop, and then it repeats again. So subtract HP, there's minus 50. And subtract HP, and now Monster 1 has negative 50, and Monster 2 has 0. And now this thing is false, so it breaks out of the loop. So see where the yellow arrow went down here. And now we test to see which of these conditions is true. Negative 50 compared to 0, we'll jump down into here and say Monster 2 is the winner. There's a case, though, where you want this thing to stop as long as both of these guys are alive, but you kind of want to make sure that both of them are alive, not just one of them. Because otherwise, they're both going to be guaranteed to die. So if you have a case here where, like, Monster HP had, like, 500, or this guy had 500, this guy had 100 HP. Monster 1 is definitely going to win this fight because he has 500 HP. He has 500 HP. And over the course of this, so watch what happens to Monster 2. Monster 2 is dead now. He still has 125 HP. But this thing is going to keep looping. It's going to keep fighting even though Monster 2 is dead already. So he's at minus 25 HP and he's still doing damage to Monster 1.
He's a zombie now.
Because this thing only tests to see if Monster 1 is still alive. So you actually need to add both if Monster 1 is alive and Monster 2 is alive. This right here will make sure that both monsters are still alive. Otherwise your loop will go on until Monster 1 is below 0 HP all the time. So if I put a breakpoint here. So now I have Monster 1 HP is 500, Monster 2 HP is 100. So I'm going to do this fight again, so watch their HPs. 350 versus 50, 275 versus 25. And now Monster 2 has 0. So Monster 1 lives with 200 HP, Monster 2 is dead. And watch where the yellow arrow goes. Now it's finally done. So, and Monster HP 1, he properly is still alive at this point, and you can tell that he won the fight. Okay. All right. So that was part 2. While we're here, why don't we do something fun with having it do random numbers, right? So random numbers are kind of cool because you can basically randomize these values here. You can either randomize the numbers that are passed in here, so randomize the HPs, which we can do. Modulo, we'll do modulo 1000 plus 500. You can do that, and let's just call it once. So now this fight will be different every time. Maybe I'll do 500 HP. So you don't necessarily know which monster is going to fight every time, or which monster is going to win every time. If I just do this 5 times, I will get 5 different fights that occur because of the random number. So Monster 1 has 5 different HPs. Looks like Monster 2 is the winner almost every time still. He still has like 200 HP left. So let's give him maybe 700 HP. Now I just want to see Monster 1 win sometimes.
I think it's 50%.
Yeah. Does it give him 1,000 base HP? The problem is Monster 2 does like triple damage of Monster 1. Still barely losing. He's losing with like 66 to 25, 31. So I think we just need to add a little bit more. Give him 200 more HP. I just want to see sometimes Monster 1 win. Here we go. So Monster 1 won the first fight. Monster 2 won the second fight. 1 won the first fight. Monster 2 won the second fight. So it's very close, this battle here. So if you wanted to, you could toss in random numbers here. You can also put the randomness inside the function if you wanted to. So this thing here is, let's just do 1500 HP. If you wanted to, you can make the damage random too. So here, we can make the damage be random between 0 and their strength. So we can just do rand modulo their strength. And now they lose a random amount of damage. So even between two monsters with the same exact HP and damage, you'll get different. So I'm just going to give them both 200 HP and make them both do 25 damage. So now the fights look like they're completely even, but there's randomness inside of it. So you don't actually know who's going to win until you actually do the fight. Yeah, like this one here, Monster 1, 1, Monster 2, 1, 1, Monster 1, 1, 1. Just to make this a little bit easier, I'm also going to do this. Right here. There's monster fight. So monster 1, 1. Looks like monster 1, 1, 4 of those. So this is a very kind of tiny example of how to do a loop to repeat behavior. But this is kind of the building blocks for how games are built. Like every game involves loops in this way. So thinking about how games utilize while loops and for loops is going to be really important for making your own games. Specifically even in tic-tac-toe. So we're going to do an extension of this for our tic-tac-toe. All right, questions? All right, if there's no questions, then I think we jump right into the final here. So let me show you guys what this this program looks like. So this is what the final tic-tac-toe program is going to look like for everyone. So you have tic-tac-toe. That's my very badly drawn tic-tac-toe board, but you guys are going to draw something similar. So you type in numbers by row and column to put down a piece. So if it's currently X's turn, so if I want to put one in the middle, I go to row 1, column 1. So it goes 0, 1, 2, okay? Remember in that order. So I do row 1, column 1. You see an X shows up there. Then it's O's turn, and I do, maybe I want to put one in the top center here. So it's row 0, column 1, like that. And then X puts one in row 1, column 0, like that. And then circle's going to block row 1, column 2. And what happens, though, if I enter in an invalid number, it tells me, please enter a valid number. If I try to put in a number for a spot that's already taken, like if I try to put the middle again, it tells me that that spot is taken already. So it's X's turn, so I'm going to do row 2, column 0. And then I'm just going to let X win here. So I'm going to get a diagonal victory here. Row 0, column 2. And then that's what you get at the end. Okay, the winner is X. So this is the final program for what the behavior is, what the game is supposed to do. Yeah.
Is there one like no side wins?
If no side wins, a draw. Yeah, you know, a stalemate. That's something else that's in there. So I just want you guys to worry about winning as opposed to detecting stalemate. Stalemate is a nice thing to detect, but if you don't get to that point, I'm not worried about it for the final. This is kind of like a simpler version of tic-tac-toe. It's kind of more about can you actually get all the other behavior in first. So this is the actual document I'm going to give you guys. This is more of a kind of like a instructional list. I'm trying to give you guys direction on how to implement each of the behaviors. So I basically broke down the tic-tac-toe game into tasks for you, into all the different pieces of what it takes to actually make tic-tac-toe happen. So this is going to be over the course of this week and next week. So this final is going to be due at the end of class next week. Okay? So we're going to have all this today as well as all of in class next week to work on it. You'll be starting off with a tic-tac-toe program from the book. So you can use this as a starting point, which I think is very helpful because we already did this last week. Or 2 weeks ago we did this. So we're going to start with this as a template, and you're going to build on that to basically make this game. So I just want to go down the tasks with you, and then I'm going to give out this document, and you guys can start. There's tic-tac-toe. There's a lot of pieces actually going into it, but if you break it down to small chunks, it's actually very manageable. For instance, the first thing you're going to do is you're going to just draw the board. You're going to draw an empty board representing empty spaces with the dash symbol. You're going to read player input, meaning asked for a row and column. You're going to repeat that behavior of asking for a row and column. Then you're going to keep track of whose turn it is, whether it's O or X's turn. Then you're going to use a function to draw the board instead of just drawing the board with a for loop every time. Then you're going to determine whether the game is over or not, so whether someone won. And then finally, the last two things are going to be making sure that what they typed in is valid. So making sure that they didn't type in like 32 for a row, as well as making sure they didn't take a player spot that's already taken. Okay. So what I want to do is I'm going to give you guys this final, I'm going to put up on Zool. And I recommend that you guys start with the CPP file that I put in there. The tic-tac-toe board. Start with that, add that to your project, and then go down the list in the order of the tasks that I bring out. And I give you guys some details for like even some pseudocode for you could basically take this code and use it in your program to help you. I even wrote you the first condition for detecting a win in the horizontal first row. So you can use this to determine if there's a winner. All right. So for the rest of class today, I'm going to be walking around helping people. Get started on this and do as much as you can in class today. You have about 3 hours. The rest of the class is basically a free lab. So spend your time wisely as I'm here.